guys, welcome back to Wong Chemistry channel. This is the part 7 of your 7.1 acid and bases. In this video, we are going to learn on how to calculate the pH of our buffer solution. I hope you remember from the previous video, we have two types of buffer solution. The first one is acidic. The second one is your basic buffer. So we are going to learn on how to calculate the pH for both of the buffer solution. Alright, so how can we calculate the pH of a buffer solution? Very simple, okay? First, you are going to identify the type of the buffer solution. So we have two types, whether it's an acidic buffer or whether it's a basic buffer. So first and foremost, you need to know the buffer solution that you have is an acidic buffer or is a basic buffer. Alright? Second, you can predict the pH value already, knowing that your acidic buffer, the pH shall be less than 7. Your basic buffer, the pH shall be more than 7. So you already can predict the pH after you know the type of buffer. Alright? Next, you can choose the appropriate Henderson-hasselbalch equation. We have two equations over here for you to choose. So, according to the equation that I give to you on the screen, which one do you think is used for the acidic and which one do you think is used for the basic? Looking at the information, the pH equals to pKa, your acid, everything about acid, plus log conjugate base over acid. And the acid that I mean over here is a weak acid. Alright, it's a buffer. Therefore, this equation is definitely for your acidic buffer. Okay? Because it's for the pH, having the pKa, having the conjugate base over acid. Alright? And since we only have two types of buffer, acidic buffer and basic buffer, if the first equation over here is for your acidic buffer, automatically the second equation over here is for your basic buffer. And why is that for a basic buffer? Look at the formula, guys. Is the POH equals to pKb plus log conjugate acid over weak base. So, everything is about basic buffer, okay? But the problem arises over here is I said we want to calculate the pH of our buffer solution. And looking at the basic buffer, you only have your POH calculated. And how can I change the POH to pH? Simple. Your pH plus POH equals to 14. So after you calculated the POH, you can easily change it to pH by using this formula. Okay? So it's very important to know the type of buffer that you have so that you know which equation for you to use in your question. Alright? So if right now in your beaker you are having a weak acid, okay? So if your question you are having a weak acid and also a conjugate base to that particular weak acid. Bear that in mind, weak acid to the conjugate base happen because of the donation of the H+. Okay? So you have your weak acid and your conjugate base over here. Straight away, it will then be your acidic buffer. Okay? You should know that the pH calculated must be less than 7 because it's an acidic buffer. So pH will be always less than 7. And since it's an acidic buffer, guys, what equation will you use? The Henderson-hasselbalch equation that you will use will definitely involve the acid. Your pH equals to your pKa. Your pKa over here is a negative log Ka. Always remember that. Plus the log of the concentration. I hope you can see over here. They are concentration. Molarity of the conjugate base and also molarity of your weak acid. Bear that in mind, the acid I mean over here is a weak acid. Alright? And I hope you can press the calculator correctly. And one of the important thing is, the log over here is the log of the entire conjugate base over acid. So you need to calculate the conjugate base over acid before you can log them. Okay? So this is the equation that we will use for your acidic buffer, where we are calculating the pH straight away from your Ka value and also the concentration of your conjugate base and your weak acid. Okay? Simple. That's it. And how about this question? if you are having a weak base and then a conjugate acid, the respective conjugate acid, bear that in mind, from your weak base to become your conjugate acid, you are adding in 1 proton. Okay? So you're having the weak base to the conjugate acid, automatically it's a basic buffer. And guys, if it's a basic buffer, the pH will be automatically more than 7. Well, it's a base, right? So whenever you are talking about a base, the pH is always more than 7. So which equation will you use for your basic buffer? Simple. The Henderson-hasselbalch equation that you are going to use for your basic buffer is your pOH. Why a pOH? Guys, it's a base. So in the base, you are having the OH minus equals to the pKb. So pKb over here, again, is our negative log Kb. So that is our pKb. And then plus the log of the conjugate acid. So the conjugate will be always on top over the concentration of your weak base. Okay? So the formula is actually very similar, but right now in the basic buffer, the formula will be in terms of base. So everything will be in terms of base, where you have the pOH, your Kb, and also your weak base and the conjugate acid. Bear that in mind, the log over here is the log of the entire term. So it's the log of the conjugate acid over the weak base. Okay? But the problem arises in here, you can only calculate the pOH. The question always asking for pH. So what do we do after you have the pOH? We are going to use the formula of pH equals to 14 minus pOH, right? Then from the pOH value, you can change it to your pH value. And bear that in mind, since it's a basic buffer, your pH value must be always more than 7. Okay? As simple as that. Alright? So always remember, the first step is definitely to identify the type of buffer. Then only you know which equation you can use for your calculation. Alright? Alright, let's try our first example over here. So in the example 1, the question asking for the pH of a solution prepared by 0.3 molar ammonia and also 0.15 molar NH4Cl. The Kb of NH3 is given. Okay? It means right now in your beaker, you're having the presence of 0.3 molar ammonia and also the presence of 0.15 molar NH4Cl. So from here, you need to determine one thing. You need to determine the type of buffer. So how can I determine the type of buffer? Simple. Looking at NH3, you know that your NH3 is your weak base, right? So if it's a weak base, straight away we know it will be your basic buffer. And the basic buffer means the pH calculated must be more than 7, right? And if that is my weak base, automatically my NH4Cl or the NH4 plus will be my conjugate acid. Remember your conjugate acid base pair? So when it's a weak base, the one that you will obtain is your conjugate acid. And you can see that by seeing the differences. NH3 then become your NH4 plus, addition of 1 proton. That's why from the weak base, we become conjugate acid. Okay? And right now, you have identified the type of buffer, which is a basic buffer. What formula will you use? Definitely the pOH, because it's a basic buffer. So whenever it's a base, we definitely calculate the pOH. pOH equals to pKb plus the log of our conjugate acid, which is the concentration of NH4 plus, the conjugate, over the concentration of our weak base, which is your NH3. This is the formula that we are going to use. Okay? Your pKb right now is the negative log of your 1.75 times 10 to the power of negative 5. That is our pKb. Plus log of the concentration. The concentration is given over there, which is your 0.15 for your conjugate acid. 0.15 over 0.30 for your weak base. And that's it pretty much. You will just press your calculator over here. When you press your calculator correctly, the POH that you obtain over here will be 4.46. And guys, remember, this is only your POH. Question asking for pH value. So how can I find the pH value? Simple. pH will then equals to your 14 minus POH, which will then be 14 minus 4.46. Therefore, the pH calculated over here must be more than 7 as we predict above. The pH calculated 9.54. This is the pH value for your buffer solution. To be exact, this is the pH value for your basic buffer solution that have the presence of ammonia and your ammonium chloride. Okay, so let's try another example over here. I have my example 2. Calculate the pH of a solution preparing by 250 ml of 0.2 molar of C6H5COOH, your benzoic acid, and 150 milliliter 0.35 molar of your sodium benzoate. Okay, the Ka of your benzoic acid is given. So right now in my beaker, I am having the presence of 250 milliliter of 0.2 molar of my C6H5COOH. And in the same beaker, we are pouring in 150 milliliter of 0.35 molar of your sodium benzoate. Okay, so that is the question. Alright, so the first thing we need to identify the type of buffer by looking at what do you have in the beaker. C6H5COOH, that is my weak acid. Alright, and that will automatically be my conjugate base. Correct? Yes. And since we are having the weak acid, straight away, that will be my acidic buffer. So, you need to know what type of buffer first. Knowing that it's an acidic buffer, the pH value calculated must be less than 7. Agree? Therefore, the formula that you will use for this acidic buffer will definitely be your pH. Because it's an acid, so it must be starting off with the pH. pH, everything about acid, pKa plus the log of conjugate base. So your conjugate base C6H5COO minus over the weak acid C6H5COOH. Okay, so this is the formula that we are going to use. But the question right now having some problem. Can we use this concentration straight away? We cannot use this concentration straight away because both of this is the concentration before you mix them up. Okay? So bear that in mind, when you mix them up, then only you will have your buffer solution over here. And in this buffer solution, the volume total right now will be a 250 plus 150 ml. So the new volume or the new buffer solution that you obtain is a 400 milliliter solution. And when it's a 400 milliliter solution, guys, will the concentration remain the same? No, the concentration will change, okay? Bear that in mind, the concentration that they give to you is the concentration before you form the buffer solution, okay? So right now, we need to calculate the concentration of the weak acid and the conjugate base after the mixing up. In the other words, we need to find the concentration of your weak acid and your conjugate base in the buffer solution, okay? After they mix up, agree? So how can I calculate that? Very simple. We are going to use M1V1 equals to M2V2. So M1V1 is before our mix up. M2V2 is our buffer solution. In the other words, after we mix them, okay? So we can calculate for the C6H5COOH first. Okay? So the M1 that we have is the one that given in the question before you form the buffer. So the V1 is the volume that we use. Okay, 250. Equals to the M2, the one that we are looking for, the new concentration in the buffer solution. So the V2 is 400. Why 400? Because in the buffer solution, you have 400 milliliter. Okay? So the M2 right now is equals to 0.125 molar. Alright? And bear that in mind, this is the concentration of your C6H5 in buffer solution. Okay? So this is the concentration that we will use into this formula. Okay? Next, you can calculate for the conjugate base. Your C6H5COO minus in buffer. We are looking for that in buffer. So the one in buffer right now will be your M1 before the buffer. 0.35. The V1, 150. The M2, we are looking for it. The V2 remain 400, your buffer solution. So the M2 calculated over here is 0.1313 molar. Alright? So this is the concentration of my conjugate base in the buffer solution after we mix them up. So this is the weak acid in the buffer solution. That is the concentration. Okay? So this is the two concentration that you'll put into the formula. And once you have the concentration, let's try the formula. The pKa over here is equals to negative log, the Ka value 1.8 times 10 to the power of negative 5. Plus the log of the concentration of my conjugate base, 0.1313, over the concentration of my weak acid, 0.125. Okay? Make sure you put in the correct value every single time. And of course, you need to press your calculator very, very correctly. Make sure you know how to press the negative log and log over here. And the pH value calculated, 4.766 pH. Okay? And as predicted, the pH value right now must be less than 7. And you are done. Okay? And it's not needed to do the extra step because that is my pH already. Agree? Simple. Just slightly different from the previous question is your volume changes. So when the volume total change, the concentration also change. You need to find the new concentration in their buffer solution. Okay? Next and the last example for this video, your example 3. Calculate the pH again of a solution prepared by 100 milliliter of 0.5 molar of your CH3NH2 and a 5 gram of CH3NH3Cl. So the Kb value is given of your CH3NH2. Okay? So right now in your beaker, what have you put in? You have put in your 100 milliliter of a 0.5 molar of your CH3NH2. The next thing that you put in into the same beaker is a 5 gram of your CH3NH3Cl. Okay? First and foremost, identify whether it's a buffer or not. It's a CH3NH2, that is my weak base. Okay? Due to the presence of your NH2 there, we know that it's a weak base. And then look at the changes over here. Having the CH3NH2 and then having your CH3NH3 positive. Okay? So your CH3NH3 positive straight away my conjugate acid. And by having the weak base and the conjugate acid, you know that this thing will be our basic buffer. Agree? Okay? And since it's a basic buffer, you know that you must calculate the pOH first. Okay? So make sure you know which formula to use by now. And since it's a basic buffer also, we know that the pH calculated must be more than 7. Alright? So identify the type of equation or the formula that you will use for this basic buffer. The formula that we will use, definitely pOH equals to pKb is a OH, is a base, so Kb, alright? Plus the log of the concentration of my conjugate acid today, CH3NH3 positive, over the concentration of my weak base, CH3NH2, that is my weak base, okay? So this is the formula that we will use. So the question is, can we use the concentration straight away? Do we have any volume changes? No. The volume total remain 100 milliliter, right? So you put in your 100 ml and then you plus a 5 gram. So the volume total remain 100 milliliter. That's why the concentration of your CH3NH2 over here, that equals to 0.5, can be used, okay? But the problem arises is, for our conjugate acid, we don't have the concentration. We only have the mass. So what do you need to do when you have the mass, but you need the concentration? We need to find the number of mole. Therefore, the first and foremost, you need to calculate the molar mass of your CH3NH3Cl. Okay? Find the molar mass of this thing, which is equals to 67.50 gram per mole. Once you have the molar mass, you can find the number of mole. So the number of mole over here, I hope you still remember the formula. Mass over molar mass. The mass is 5 gram over the molar mass of 67.5 gram per mole. Okay? From that, you will then get the number of mole, 0.074 mole. This is the number of mole only, but we need the concentration. And I hope you remember the molarity formula over here is what? The molarity of the formula is equals to the number of mole, okay, over the volume of solution. But if you remember, the volume of solution that we need in here is liter, right? And the volume of solution that we have right now is 100 milliliter. Can you see the 100 milliliter? So that is my volume of my buffer solution, okay? Therefore, the volume solution will be 0.1 liter. Okay, so let's calculate the concentration of our conjugate acid. CH3NH3Cl will be the number of mole over the volume of solution in liter. That will equals to 0.074 over 0.1 liter. Then the concentration calculated is 0.74 molar. Okay, so right now you have the concentration of your weak base given. You have the concentration of your conjugate acid calculated, 0.74. You can move to calculate your pOH of your buffer solution. pOH equals to negative log of the Kb. Kb given 5.45 times 10 to the power of negative 6 plus the log of the concentration of your conjugate acid, 0.74 over the weak base, 0.5. And then press your calculator very, very correctly. Then you should be able to get your answer over here is 5.43. And I hope you remember, this 5.43 that you calculated is only your pOH value. Remember, it's a basic buffer. So we're using the formula of your pOH only. Okay? And from here, we can easily change it to your pH value, where pH equals to 14 minus pOH. That will then equals to 14 minus 5.43. Therefore, the pH value calculated in this question is 8.57. As we all agree, the pH value right now must be more than 7 because it's a basic buffer. Okay? So whenever you read your question, make sure you do one thing. You identify the type of buffer first by looking at whether weak acid or weak base is present. So if you're having the weak acid, then it will be an acidic buffer. If you're having a weak base, then it will become a basic buffer. And the most important thing, after the type of buffer, identify the type of formula that you can use. If it's a basic buffer, then we can only calculate the pOH with the pKb value and the weak base, and your conjugate acid. But if you are having an acidic buffer, then you can calculate the pH straight away by using the Henderson-hasselbalch equation of pH. Okay? And that's it about this video. Alright? And this is how we can calculate the pH value of a buffer solution. Bear that in mind, we have two types of buffer, acidic buffer and basic buffer. That's why you have two different equations for you to calculate the pH or the pOH of your buffer solution. Alright? If you have any questions, drop it in the comment below and I'll get back to you as soon as I can. Make sure you like the video, subscribe to my channel, and I'll see you again in the next video. Thank you for watching.
TunePocket.com